Hello, my name's Thanom and I'm from UNSW. Today I'm working through some of the Math 1011 calculus problems from the section on limits. So this is question 3. They've given us a graph of a function and we're asked to evaluate or explain why these don't exist. I'll also address some of the aspects of part B, which is asking about whether the function is continuous or discontinuous at points. So in parts 1, 2 and 3 we're looking at the limit as x tends to 2, right? But to do that we need to look at the limit as x approaches 2 from the left, that's what x approaches 2 minus means, and the limit as x approaches 2 plus, which means we're coming from the right. So first of all, if I'm coming from the left, that is if I'm approaching 2 minus, you can see the function is going to get closer and closer to the value of 2, the y value of 2 there. So that means our limit as x approaches 2 minus is 2. That's our limit from the left. However, if we approach 2 from the right, as x approaches 2 plus, we can see our function will get closer and closer to the value of 1, and so our limit as x approaches 2 plus of f of x is going to be 1. Now, these are different values. The limit from the left and the limit from the right are different values. They approach different points here. So that means that this limit overall, as x approaches 2, does not exist, right? It does not exist since the limit as x approaches 2 minus of f of x does not equal the limit as x approaches 2 plus of f of x. Okay, now that also means that f of x is discontinuous at x equals 2. If it was going to be continuous at x equals 2, the limit first of all would have to exist, and not only that, it would have to also equal the function value at that point. But this limit doesn't even exist, so it's got no chance of equaling the function value at that point, f of 2, so it can't be continuous. So now looking at the limit as x approaches 3, so we really need to consider as x approaches 3 from the left and 3 from the right, and then if they're the same, overall we can say what the limit as x approaches 3 is. You can see from the graph that they are approaching the same point there though. But let's just write it down. So the limit as x approaches 3 minus, that is approaching from the left, if I approach 3 from the left, the function is going to get closer and closer to the value of 2. If I take the limit as x approaches 3 plus of f of x, and I come in from the right here, x approaches 3 plus, you can see my function is going to get closer and closer to 2. Okay, so since these are both equal to each other, overall we can say the limit as x approaches 3 of f of x is going to be 2. Right, because these are the same value. Notice that the function value at 3 is actually 4, right? We've got an open circle here. The function value is not 2, despite the fact that the limits are 2, the function value is 4. So f of 3 is 4 here, right? So we have the limit as x approaches 3 is 2, but the function value is 4. So what this means is that f of x is not continuous or discontinuous at x equals 3, right? Not for the same reason here, right? Here it was because the limit didn't exist in the first place. Here the limit exists, it's 2, but it's discontinuous, it's not continuous because the limit is not the same as the function value. So fx is discontinuous at x equals 3 since the limit as x approaches 3 of f of x does not equal f of 3. So our function is discontinuous at that point there.